Hello and welcome back. Let's expand our knowledge into surface integrals. Now we are used to 3D space. For example, line integrals can be thought of integrals in 3D space that span up like this. Pretty hard to visualize, but they essentially are some line in 3D space, and we want to see how much area we have down in this section right here. Now let's talk about surface integrals. The first type of surface integral that we will talk about is a scalar surface integral, and then or scalar field surface integral, and then we will talk about vector field surface integrals. So a regular surface integral would have some section, we'll call it D, down here on one of the planes. It could be on this plane, it could be on this plane. And this section will span up and create some other section, say up here, that we can now find the area of this. When we talk about surface areas of vector fields, we will be calculating how much of the vector field goes in and out of the surface. So let's hop into some notation. A regular surface integral is denoted by the double integral over S of our scalar function with respect to a section of surface, a small section of surface. And this can be broken down to equal the double integral over D of our function of our new parametrization of two variables, because remember, we are talking about surfaces now. So if you do have to go back to the parametric surfaces video, please do, so that you can get a little refresher before we talk about all of these parametric surfaces in surface integrals. So first we have this, and then we're going to take the magnitude of the partial derivative of our parametric surface with respect to both variables. We're going to cross them, and then we can take this whole integral with respect to a small section in area. That would be the small section in area of D, like we showed earlier. So that's a surface integral. Let's hop into an example. Let's say we want to evaluate the double integral over, I believe it is x plus y plus z, with respect to the surface. This is going to equal this side, but now, since, I'll just simplify this for us. It's actually going to look more like that with x's and y's, because our surface is the plane z equals y plus x, or x plus y, from, and we'll say x is greater than or equal to 0 and less than or equal to 1, and same with y. So this is a pretty simple surface integral. There will be much more complicated ones. but let's just talk about a simple example first. So let's parametrize this surface. Well, this is pretty easy since we have an explicit function of x and y. So we're just going to have x, y, and what does z equal? X plus y. Now we will have to take the partial derivative of this parametrization vector with respect to x and y. Our x is equal to 1, 0, 1. And our y is equal to 0, 1, 1. We will now take the cross product of these two vectors. Which, if you recall from linear algebra, is equal to the determinant of this matrix. You can work this out yourself, but what you're going to get is the vector -1, -1, 1. Very simple vector. Now, as you can tell from our formula, we will need to find the magnitude of this vector. This will be √3. Remember, it is -1 squared plus -1 squared plus 1 squared, all under a square root, which will give you √3. So we can now say that this is √3, and this is, say, dy dx. And our f of r of xy will just be this, but replacing z with x plus y. So that is just 2x plus 2y. Okay. Let's erase this since we have it all up here. And we remember that x and y both span from 0 to 1. This is a very simple double integral that we can just evaluate. So now we can take our 2√3 out, factor these 2's out, take the √3 out. Okay, let's integrate with respect to y. We get xy plus 1/2 y squared, evaluated from 0 to 1. Remember our dx because we have not evaluated our x integral yet. This will equal x plus 1/2 dx. Let's integrate with respect to x. We will get 1/2 x squared plus 1/2 x, evaluated from 0 to 1. This will give us 2√3 times 1/2 plus 1/2, which is just 1. Our final answer is 2√3. So that is surface integrals. I hope to catch you in the next video where we talk about surface integrals of vector fields and then get into some strategies for evaluating these types of surface integrals. Thanks for watching.